Hello everyone, welcome back to this video series on clinical SAS ADaM programming. In this video, we will see how to create ADCM dataset for a parallel arm study. So ADCM stands for Concomitant Medications Analysis Dataset. So let us now go to the lesson description and see what will be covered in this lesson. So in this video, we will see Concomitant Medications Analysis Dataset complete programming covering start date imputation, end date imputation flags creation, on treatment medications flag creation, prior medications flag creation, study day creation, etc. Let us now move on to the programming specification. So here we have been given the variable name, variable label, and the derivation algorithm for each of the variables. In concomitant medications, most of the variables are direct copies from SDTM domain, SDTM CM domain, and we create some derived variables. So as part of, if you are watching my previous videos, the derivation convention provided here in the comment column uh, says this, like whenever it is mentioned as the domain name dot variable name, it means it is a direct copy variable into the ADCM dataset here. So study ID, USUB JD, CMSIG, all the way till CMSTDTC. So these are direct copies in ADCM dataset from SDTM CM dataset. Now let us move to the derivation of ASTDT, so which is analysis start date. Here it says populate using CMSTDTC. So when CMSTDTC is full, convert it into numeric format, which means when we have full year, full date, which is year, month, and day collected, so we are being directly asked to convert it into numeric format. And then when only day component is missing, use first day of the month. So there can be cases wherein the subjects may not be able to recollect full dates, so we'll have partial dates in our CMSTDTC. In those cases, so we are being given certain rules on what has to be considered as the missing component values. So we will be using those for our analysis start date creation. So when only day is missing, we are being asked to consider that as the first day of the month, which means if a subject, say for example, said I started taking this medication in Jan 2010, so and could not recollect the exact day, so we are assuming that the subject had taken started taking the medication on 1st of Jan 2010 for analysis purposes. So similarly, when month component is missing, so we are being asked to make use of the value of January, which means if someone said that they started taking the medication in 2012 but could not recollect the month or day portion, so we are assuming that the subject has started taking medication from 1st Jan of 2012. And then when full date is missing, so we are being asked to use the value of treatment start date, which means if the subject could not recollect the start date of medication, even the year. So in those cases, so we are being asked to use the value from ADSL dataset from the variable trtstd. And then we have this flag called analysis date imputation flag. So ASTDTF. So date imputation flag. So what do we store in this variable is the level of imputation, the highest level of imputation done when creating ASTDT. So if we are imputing full date, which means the highest level of imputation is done at year level, which means year, month, and day are imputed. So in those cases, we populate it with the value of Y. And if we are imputing it at month level, we populate the value of M. And if we are imputing only day, so we populate it with the value of D. So if we see here, if the start date is completely missing or missing year, then ASTDT F is equal to Y. Else if start date has month missing, then populate as M. Else if start date has day missing, then populate as D. And then we have the study day variable creation. So ASTDY, which is analysis start relative day. So here we are being given the algorithm as if analysis start date is greater than or is equal to treatment start date, populate as difference between treatment analysis start date and treatment start date and add 1 to the difference. Else if analysis start date is less than treatment start date, populate as the difference between analysis start date and treatment start date. And then CME and DTC is a copy from the same named variable from SDTM CM domain. And then we have analysis end date. So here we are being said that populate using CM, CME and ETC. When CME and ETC is full, convert it to numeric format. When only day component is missing, use last day of the month. So for example, if someone said like they started taking they ended the medication in Jan 2010. So in that case, we'll have to use the last day of that month. So in January, we have 31 days. So we'll have to populate it with the value of 31. Say for example, if someone said they took the medication in the month of, they stopped taking the medication in the month of June, we will have to use a value of 30 because June has 30 days in that month. The only complication could come for the month of February. So when we'll also have to check for the cases where it is whether the year is a leap year or not. If it is leap year, we'll have to populate it with 29. Otherwise, we'll have to populate it with 28. But again, we have some workarounds or easy way of handling this in SAS. We will see that when we are looking at the programming. And then when month component is missing and if the year is same as the treatment end date, so we are being asked to use the treatment end date. Otherwise, if it is a different year, so we are being asked to use 31st December for that year. So for example, if the subject ended taking the medication in the year 2010 and the uh, concomitant medication also was stopped in the same year 2010. In that case, we are being asked to populate it with the value from TRT EDT. But if it is 2009 or 2011, any year other than 2010 in this example, we'll have to populate with the value of 31st December of that year. And then when full date is missing, use treatment end date. So, and then we have similar to the start date imputation flag, we have end date imputation flag. So same as this flag, we will populate it with either Y, M or D. So based on the highest level of imputation that we are doing. And then we have CMENRF, which is a copy from SDTM CM domain. And then we have study day for analysis end date similar to ASTDY. And then we have on TRTFL. So in general concomitant medications, so these kind of flags will become important. Most of the variables apart from date imputations will be copy variables from SDTM dataset. So here if we see this on treatment flag, so we are being asked to populate as Y if subject took at least one dose of medication in between treatment start and treatment end date. So this could be because the subject might have started the treatment and ended in between the subject. The subject might have started taking a concomitant medication. What do we mean by concomitant medication? Any medication other than the treatment that is being investigated. So the treatment that is being investigated, the start and end dates would be captured in our TRT SDT and TRT EDT. So we are being asked to check the other medication start date in reference to the study medication start and end dates. So if the subject has taken at least one dose of the concomitant medication in between treatment start and end date, so we'll have to consider it as on treatment flag. So what can be the cases? The subject might have started taking the medication before treatment start date and then ended in between the TRT SDT and TRT EDT. So or they could have started and stopped in between TRT SDT and TRT EDT, or they could have started in between treatment and is still ongoing. Or there can be a fourth case wherein the subject might have started taking the medication even before TRT SDT and is still continuing, which means the end date will be somewhere after our TRT EDT, which means the subject was still taking the medications while the date values are in between TRT SDT and TRT EDT. So we'll have to see all the possibilities and handle this in the program. So though the definition is looking simple here, so we'll as a programmer we'll have to think about all the cases which could get classified as on treatment. And then we have pre-FL. It says populate as Y if the medication started and stopped before treatment start, which is before TRT SDT. So in simple terms, the AE and DT should be before TRT SDT. So for a medication to be called as pre-treatment flag. And then we have some variables which are dependent on ADSL, which they are either copies from ADSL variable or which involves some minor modification from ADSL. So here if we see SAFFL is a direct copy from ADSL, TRTA. So we are using the value from TRT01A and assigning it to TRTA variable. Similarly for TRTAN, so we are using the value from TRT01AN and assigning it to TRTAN. And then we have certain other variables which are copies from ADSL dataset into ADCM dataset. Now we will move to the programming. So here on the left hand side of my screen, I have my program that creates the ADCM dataset. On the right hand side, here I have my input dataset, the intermediate dataset that gets generated from my program, and also the final output dataset. So similar to my previous videos, all the data that is required for creating this lesson's final output, which is ADCM, is stored in a program. So I am including that program here. So when I run this line of code, all the all the program that is present in that second SAS program gets executed and the dataset gets created in my work library so that I could continue programming further. So now we'll move to the core programming of ADCM. So here we are reading and processing input datasets. So we are reading concomitant medication and sorting it using proc sort procedure based on the values present in study ID and useObjD variables and storing it in a new dataset called CM01. And then similarly we are sorting ADSL dataset based on study ID and useObjD again using proc sort and then creating a new dataset called CM02 by merging CM01 and ADSL. And then we are keeping only the records for subjects who are present in both ADSL and CM dataset. And then, so this CM02 is now our base dataset for our ADCM dataset. And then we are in this next step we are creating derived variables. So we are using CM02 as input and then creating CM03 as the new dataset. So here in this case the first derived set of derived variable that we are creating is ASTDT and ASTDTF. So here we were asked to when the date is full. So if we are using ISO 8601 notation, when the dates are full, we'll have a value of, we have a length of 10. So we are converting that to numeric format using input function by using in format of YYMMDD10 dot. Otherwise, if date is completely missing, as per the specification, we were asked to use the value present in TRT SDT variable from ADSL for ASTDT. So again, ASTDT-F is kind of dependent on what is the level of imputation that we are doing in ASTDT. So when date is completely missing, we are replacing the full date, which means the highest level of replacement is being done at year level. So we have to populate ASTDTF as Y. So we are doing that in the same line. So instead of doing it in separate step, as the condition that has to be checked for ASTDT and ASTDTF is the same. So we are assigning the value for both variables in single do group here, do and end statements. And then we will move to the next line of code. So when the length of CMSTDTC is equal to 7, so we are checking for whether the date has only year and month components available, which means the day is missing. So when the day is missing, so we will have the length of CMSTDTC is equal to 7. In that cases, so we were asked to use the value of 01 for imputation for that day component. So here what I'm doing here is, so initially I'm using CMSTDTC and then concatenating 01 to it. So in this CMSTDTC, when the length is 7, we know that the date value only has year and month. So for that we are directly concatenating 01. So this will become, say for example, if we had a date like 2010-10, which is October 2010. So we had to use 01 for day component. So this concatenation will give us the value like 2010-10-01. And then that concatenated value is a full date. Now we can apply input function and then convert it into numeric value using YYMMDD10.in format. In this step, what is the level of imputation that we are doing? The highest level of imputation is that is being done is our date value. So we are using the date imputation flag value as D for ASTDTF. And then we are left with the case wherein the only year is present. If only year is present, we were asked to populate it, consider it as January 1st. So we are concatenating 01 for month and 01 for day here to the value of only when year is present. So for example, if we had a value like 2021, so the length would be 4. In that case, we would the below two lines of code gets executed. So we had the value of 2021 here. For 2021, we are concatenating the text hyphen 01 hyphen 01. So that date value would become 2021 hyphen 01 hyphen 01. So that can be converted now to this will now become a full date of 1st Jan 2021, and that will be converted to numeric value using input function and yymmdd10.in format. The highest level of imputation that is being done here is at month level. So we are imputing both month and day, but the highest level of imputation is at month level. So we are populating M in ASTDTF. So this completes our ASTDT and ASTDTF derivation as per the specification. Now we have our AENDT and AENDTF derivation. So here I am creating a new variable called trtey by extracting the year component from trtedt. So why this is being done is as per the specification. So we were when only year is present in uh, concomitant medication end date, we were asked to check whether that year is equivalent to and year of treatment end date. So we could in fact make use of the same logic here directly in this code, but I personally prefer having it stored in a separate variable so that the comparison becomes easy. So I am extracting the year portion from trtedt, which is a numeric variable. So in order to extract year, month or day from numeric date values, we'll have to use year function, month function, and day function. So if the date values are present in character format, we use substr or scan function to extract them. But if they are present in numeric, we will have to use the year function, month function, or day function to extract year, month, or day respectively. So here I am using year function to extract the year component from TRT and then so the return value by year function is a numeric value. So but the CMA ENDTC will be a character variable. For the comparison to occur in between character to character, I am making use of put function and then converting it to character value and using 4 dot format. And then that year value will be stored in character format in TRT variable. And then we are now coming to the core derivation of our AENDT. So if the date is full, so we know that the total number of characters will be 10 in CMENDTC. And then we are directly converting it into AENDT by making use of YYMMDD10.in format. And then else if missing of CMENDTC, when date is completely missing, so we were asked to use the value from TRTEDT variable for AENDT. So I just wanted to cover one thing. So TRT-SDT and TRT-EDT, we have fetched it from ADSL in this merge step. So because they are not part of SDTM CM dataset, but they are part of ADSL. So when we merge this ADSL, we are fetching all the variables from ADSL into this dataset of CM02. So we will be directly be able to make use of the variables which are required from ADSL in these equations. So here we are populating it as ANDT value with the value from DRT EDT. And then the highest level of imputation that is being done here is at year level. So we are populating Y in AENDTF variable. And then in the next step, we are checking for the cases where the length of CMENDTC is 7, which means year and day component are present and the year and month component are present and day component is missing. So in that cases, we were asked to populate it with the end date value of that particular month. So the logic here is to make use of intnx function. So it actually returns the uh, start or end date of a particular interval. So here we are requesting for the interval of month. So the intnx function takes the interval as the first argument and the start date as the second argument and the interval increment as the third argument and the alignment, whether it is start or end as the last argument. So we know that the date is partial here. So but IntNX expects a numeric date value for the second component. So we know that when the length is 7, we only the day is missing. So but we are imputing it, we are trying to impute it with the last day of the month, but we do not know what is the last day of the month. Otherwise we'll have to check for whether it is Jan, Feb, and we also have to check whether it is a leap year or not in case of Feb month. So in order to avoid that, what we are doing here is, so we are temporarily converting the existing year and month value to the start of the month. For every month, the start day will be 01. So we are temporarily converting the known partial date to start day of the month. So say for example, if I have a value of 2010 June, so this temporary start date will become 1st June 2010. So in this third argument, when I say 0, so I am asking the SAS IntNX function to return the value from the same month, but I am saying the end date value. When we say 2010 June 1st, it by SAS by default knows that it is month of June and the year is 2010, and what is the end date of that month. So what will be the value? It will be 30. So for example, if the partial date is 2010 February, so then what will be the start date? So it will be 1st Feb. So when we said 0, we are asking it to return within the same month, but we are asking it to return the end value. So 2010 is a year, leap year, and then Feb is the month. So what will be the end date within the same month? It will be 29. So it will return the value, date value of 29th Feb 2010. Say for example, if it is the same case of Feb, but the year is 2011. So what will be the temporary date value get resolved to? Because we are concatenating it with 01. So the temporary date value will be 1st Feb 2011. And then we are requesting SAS to increment it with the 0, which means in the same month where we are asking it to return the end date of that month. So what will be the end date in Feb 2011? So it is not a leap year, so the end date will be 28. So that value will be written. So we are making use of IntNX function and temporarily concatenating 01 to the partial date to convert it to start date, and we are also making sure that the interval value is 0, the increment value is 0, and then we are making use of the possibility of end date alignment using the E modifier here, and the first argument has to be month here because we are trying to get the next interval in terms of months. So the highest level of imputation that is being done here is only the day component. So we are populating D value to AE and DTF. And then next case, we are checking if only year is present. If only year is present, we were asked to check whether it is the same year as the year of treatment end date. So which we have fetched into a variable called trtey, and then we are checking if CME and ETC is equal to trtey. If this is the case, so we were directly asked to use trtedt and populate AE and DT, so which we are doing here. And then in the next step, what we are doing, if it is not the case, so if it is a different year from trtey, so we were asked to use the value of 31st December. So 12 for month and 31 for day. So we are populating it with that way. So we are concatenating the existing year value with the value of 1231 here. So this will become a full date, so which could be converted to numeric using input function. And the highest level of imputation that is being done here is at month level. So we will be populating it with the value of M in AE and DTF. So we have now completed the derivation of AE and DT and AE and DTF as well. So we will now move on to the next two derived variables, which is on-trtfl and pre-fl. So the definition for on-trtfl was if the subject took at least one dose in between the TRT SDT and TRT EDT, then we had to populate it as Y. For pre-fl, the requirement was to identify the medication that was stopped before our TRT SDT. So we are first creating our pre-FL. So we are checking if the medication end date is less than TRT SDT. If that is the case, we are we are populating pre-FL with the value of Y. So this completes our pre-FL. So now the next important thing is our on-TRTFL. So we have discussed, like while going through the specification, as a programmer, we will have to interpret and try to complete the programming for the definition given. So here we are checking whether the medication start date is in between TRT SDT and TRT EDT, which means the subject has started taking the medication in between those dates, which means the subject took at least one dose in between TRT SDT and TRT EDT. So this qualifies for on treatment. And then we are checking whether the medication date is in between TRT SDT and TRT EDT. So which means if the subject has has a medication stop date in between TRT SDT and TRT EDT, which means the subject has taken at least one dose while the subject is on study dose medication, which is in between TRT SDT and TRT EDT. And then there is this third case. So what is the third case? The subject could have started taking the medication before our TRT SDT and is still continuing, and it ended somewhere after our TRT EDT, which means the subject was taking this medication all through the dates between TRT SDT and TRT EDT. So those cases also have to be considered for on TRTFL. So we are checking whether start date is in between or end date is in between, or the start date is less than TRT SDT and end date greater than TRT EDT, and then populating on TRTFL as well. So this is how we will have to interpret the requirement and try to complete the programming. So again, this is one example, and the derivation could get complicated or it could be further simple based on the study specification requirements. And then we have completed our on TRTFL and pre-FL. And then there are some other variables where we are creating based on ADSL variables. TRT-AN is equivalent to TRT01AN, and then TRT-A is coming from TRT01A from ADSL. So we are doing that here. And then here we are creating the study day variables. So when if ASTDT is greater than TRT-SDT, we were asked to add the value of 1 for the difference between ASTDT and TRT-SDT. Otherwise, we were asked to add nothing. So how does this get evaluated to is if ASTDT is greater than or is equal to TRT-SDT. So this overall condition gets evaluated as true or false. If it becomes true, the value returned by this expression would be 1. Otherwise, it would be 0. So when ASTDT is greater than or equal to TRT SDT. So we were asked to add a value of 1. So this value would become 1 only if this is true. So otherwise it would become 0. So it is kind of ASTDT minus TRT SDT plus 1 or plus 0. So and this is internally handling the condition of adding 1 or adding 0 here. So similarly we are creating study end day for our uh, end relative day for A and DT variable using TRT-SDT. And then finally, we are keeping all the required variables from the specification and assigning them to a macro variable and using it in two places. First one in the retain statement. So when we specify the list of variables here in the retain statement, they appear in the same order as per the specification requirement. And then we are also keeping only the required variables here. And finally, we are sorting the dataset based on study ID, usage ID, ASTDT, CMD code, and AENDT. So here is our input dataset concomitant medication. So we had certain variables coming from our CM, and this is our ADSL dataset. And this is kind of partial dataset wherein we have only the required variables kept in this ADSL dataset here. And then we were merging this ADSL dataset to our CM01 and created CM02. So we will have all the variables pulled from ADSL into CM02 here. So we have TRT01A, 01AN and all the variables which are required for ADCM dataset were kept here. So we have them here. And then in the next step, we have created all our derived variables. So we had created our ASTDT, ASTDTF, and we had created the temporary variable TRTEY to store the year of the end of treatment date, and then we created AENDT, AENDTF, pre-FL on TRTFL, and then TRTAN, TRTA, and then ASTDY and AENDY. So we have all the variables coming here. So and then finally we kept only the required variables and sorted the data set accordingly as per the requirement. So study ID, use of JD, ASTDT, CMD code, and AENDT. So this is how we can complete ADCM dataset programming. Hope this is helpful. Thank you for watching and keep learning.